All right, people. I believe everybody's doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. Welcome, welcome, welcome. Let the people join. Let everybody come. We are going to smash this session. There will be no mercy today. Okay? And my dear NEET aspirants, you are going to love this particular session because from these topics, you can expect the questions in your NEET 2026 examination. And I will be starting from the scratch. Okay? And I'll be starting from the scratch. If you have not studied these chapters before, doesn't matter. You would be able to understand these topics if you sit over here, if you listen to this lecture very, very carefully till the end. So before that, let me know in the chats if I'm perfectly audible, visible to each and every single student. Everyone means everyone. Let me know if I'm perfectly audible, visible. And my dear NEET aspirants, smash the like button, okay? Because liking the session means marking the attendance. Everybody of you, smash the like button as soon as possible. Make it fast. Come on. I would want you guys to smash the like button first. Then only I'm starting the session. Then only I'm starting the session. Okay. So my dear NEET aspirants, at this point of time, I know each and every single NEET aspirant is having a lot of anxiety. Okay. Some students are texting me. Some students are calling me at this point of time. Sir, this problem, that problem, financial problem. Okay, I have a lot of issues at my home. I want to leave at this moment. My dear NEET aspirants, we have only 25 days left. Give your 100%. This can basically change the entire game. Okay. I have seen students who have changed the game at the end moment. So my dear NEET aspirants, you can be the one. You can be the one. And having anxiety at this moment is very much normal. Okay. So those students who are very serious about this, they are having anxiety, and which is very common, which is very normal. So let's dive into this particular session. Make sure everybody of you has already smashed the like button. Let's dive into this session, my dear NEET aspirants. Okay. So first and the foremost thing, I would want you guys to join my Telegram channel. That is t.me. Okay. / Yawar, Yawar Manzoor. So I'll be sharing each and every single thing, like you have notes, whatever the notification, every single thing I share it over here only. We have one more Telegram channel, that is t.me / Unacademy NEET English. Okay, these are the two Telegram channels you can join. Okay, so my dear NEET aspirants, let's first dive into the session. First thing, guys, I need to discuss, that is this work energy theorem. I need to discuss this topic, work energy theorem. But before this, you must have a little bit idea of what actually work is, what actually work done is. Listen to me very carefully. I would say work done. Okay, because I need to show you the previous year questions on work energy theorem. Before that, you must have the idea of what work done actually is. See, my dear NEET aspirants, session duration is going to be 2.5 hours, something like that. Now, my dear NEET aspirants, let's suppose you have got a surface over here. On this surface, there is a block. This is a block. Okay. Now, my dear NEET aspirants, let's suppose you are applying a force F on this block. Force F. Okay. And we say at an angle of, we say theta with the horizontal. So there is a block placed on the surface. You are applying force F on this block. Now, this force will have two components. This component is F cos theta. Everybody knows. This component is basically F sin theta. Yes, sir. Now, my dear NEET aspirants, if I say this block started moving in the forward direction, this block started moving in the forward direction, and it has reached this particular point. So means it has covered some displacement, I would say S. So in physics, we say whenever you apply the force on a block and it covers some displacement, it means work has been done. That is how we define work. Force, displacement. Now, I am asking you the simple question. Which of the two components, you have resolved this force, which of the two components is displacing the block horizontally? Obviously, F cos theta. So, F cos theta is creating the work. F cos theta is contributing in work. So, I can define work over here, that is this F cos theta, this force into this displacement. Because this is only creating, this is only basically performing, I would say, or displacing the block over here. So I can say, sir, I can write it like this, Fs cos theta. This is how we define work done. Whenever you displace an object with some force, we say work has been done. And you say work in this particular case will be dot product of two vectors. Guys, F dot Fs cos theta means F dot S, because AB cos theta is A dot B. So you can say this is force vector dot displacement vector. F dot S also you can write it. That is what I have, my dear NEET aspirants, mentioned over here. Okay. When a force is applied on a body, it gets displaced. Work is done. Like here, work is Fs cos theta, F cos theta into S, Fs cos theta, F dot S, where theta is the angle between force and displacement. That's it. Now, my dear NEET aspirants, there is a question which was asked in NEET 2016. Just a basic simple question, guys. I'll be showing you the killer level. I have added all the J mains questions. Okay, you see. So stick to me till the end. So my dear NEET aspirants, let me take you from the scratch first. Let me build that confidence in you. Okay. Yes. Now, boys and girls, listen to me very carefully. In this particular case, a particle moves from point this. This is the point. This is the position vector of this point. So its position vector is given as minus 2 I cap. Then we say plus 5 j cap. Okay, to this point. A particle moves from this point. Okay, this is the position vector of the particle to this point. So position vector of this particle is 4j cap plus 3k cap. You can write it something like this. Okay, yes. Then when a force on this object is acting, on this object we say force is acting. How much force is acting? So I would say this is given as 4i cap plus 3j cap. Okay. Now, my dear NEET aspirants, when you apply this force on this object, it has covered this much of displacement. You can consider this as R1. Whatever I'm saying over here, just remember directly. If they tell you this point, means this is the position of this point over here. This is the position vector of this point. And this is the position vector R2. Means simply this is the location of this point. Now, guys, how do you find displacement? Displacement means final position minus initial position. That is R2 minus R1. This is how you guys are supposed to find the displacement. Now, R2 minus R1 means this over here. It is 4j cap. Okay, 4j cap, 3k cap. Okay, now tell me, guys, here it is 0i cap. Here it is 2. So, final position minus initial. So, 0i cap, it is 0 minus of minus 2. Guys, coefficient of I here. So 0 minus of minus 2 is 2i cap. Okay. Then you have 4j cap over here. 4. What is j over here? 0. So 4 minus 0 is 4. So plus 4j cap. Then you have 3 over here. You have 5 over here. So final minus initial. 3 minus 5 is, I would say, minus 2. So minus 2k cap. This is how we define the displacement vector in this particular case. Okay. So this is 5. This over here is 2i cap plus 5j cap. And this is... Wait. This is 2i cap, 0i cap. So 0 minus 2 is plus 2. Okay, this is 4 plus 5. This will be 9j cap. 4 minus 5. Sorry. 4 minus 5. That is -1. Okay, so it will be minus j cap over here. Minus j cap. Because this is final minus initial. 4 minus 5 is -1. Yes, 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 yes. And in this particular case, this is 3. And in this case over here, it is 0. In this case, it is 0. This is 3k cap. Here it is 0. So 3 minus 0 is, I would say, plus 3k cap. Something like this. So this is the displacement vector. Now, guys, how do you define work? Work is F dot S. Work is F dot S. Now you will say, sir, work is F dot S. How do you define dot product of two vectors? Guys, listen to me very carefully. Listen to me very carefully. In this case, I would say, how do you define dot product of two vectors? Guys, this, what is the coefficient of I over here? 2. What is the coefficient of I over here? 2. So 2 into 4. So here it is 2, here it is 4. So I would say 2 into 4. So if you are doing the dot product of F and S, so means here you have got F, coefficient of I is 4, coefficient of I is 2, 4 into 2, then plus. Now what is coefficient of J over here? 3 into what is coefficient of J over here? 1. So this is -1, 3 into -1, then plus. What is coefficient of K over here? 0. What is coefficient of K over here? That is 3. So this will become 0. Now tell me, guys, this will be over here. 2 into 4 is 8. 3 into -1 is -3. So I would say this will come out to be 5 joule. This is a basic question, as simple as that. Is this clear? Please tell me in the chats. Please tell me in the chats if this is clear. Is this clear? Is this clear? This is the simple basic question. Now, guys, work done by variable force. Listen to me very carefully. Let's suppose, my dear NEET aspirants, there is a block over here. On this block, force is acting. F is equal to, I would say, 2x. Is this force constant or variable? Variable. Constant force means F is equal to 10 Newton. This is constant. So means value of this force will remain 10 Newton till the end of the universe. Okay, yes. But if I say F is equal to x, this is variable. Variable force. Okay. So in this particular case, if somebody asks you, how do you find the work done? You'll be simply saying work done is equal to integration of F dot ds. As simple as that. Sir, this formula is valid for constant force. Yes, this is valid for constant force. When force acting on the object from this point to this point is same. 10 Newton, 10 Newton, 10 Newton, 10 Newton. But if the force is something like this, I would say when x is equal to 1, we say force will be equals to 2. When x is equal to 2, I would say force will be 2 into 2 is force. Force will be 4. So force is variable. In this case, you will be using this equation to find the work done. Let's move on to the work energy theorem. I want you guys to give me 100% attention. Now, guys, see, when it comes to the work energy theorem, what does this work energy theorem actually say? See, guys, work energy theorem says work done by all the forces. Work done by all the forces is equal to change in kinetic energy. Okay, so work done on an object by all the forces is equal to change in kinetic energy. So we can say work done by conservative force. Conservative force means electrostatic force, gravitational force. Okay, like if you release an object from height h, it falls down. Here work will be done by the gravity also. That means conservative force. Non-conservative force, friction. Okay, internal force, external force, it is equal to change in kinetic energy. Guys, whatever I am saying over here, please remember directly. Don't ask me the questions at this moment. Directly see, work done by all the force is equal to change in kinetic energy. So change in kinetic energy means final kinetic energy minus initial kinetic energy. Okay, so you can say work done by all the force is equal to change in kinetic energy. Guys, you can write it like this. This work done by all the force is equal to change in kinetic energy. Change in kinetic energy means final kinetic energy minus initial kinetic energy. So you can write it like this. Final kinetic energy is 1 by 2 m v final square minus, because kinetic energy is 1 by 2 m v square. Initial kinetic energy is 1 by 2 m v initial square. Now you can take 1 by 2 m common over here. 1 by 2 m common over here. You can say v final square minus v initial square, my dear NEET aspirants. So this is how you write the work energy theorem. Let's take a look at the question. First question is, J means 2026. I would want you guys to smash the like button. Quick, everybody. A mass of 1 kg is kept on an inclined plane with 30-degree inclination. Listen to me very carefully. This is an inclined plane and this inclination is 30 degrees. On this inclined plane, my dear NEET aspirants, we have placed a mass. You have placed a mass. And this is 1 kg. 1 kg. Now, boys and girls, if this is 1 kg, what is the force acting on this in the downward direction? That is 1g, mg cos theta. Sorry, this will be mg simply over here. This one will be mg. And this component will be, if this is 30, this will be 30. So this will be mg cos 30. I have told you this so many times. Guys, if this is theta, so this component is going to be cos. And this component is going to be sine. This will be mg sine 30. Okay. Now, my dear NEET aspirants, it says that with respect to the horizontal plane, and it is at rest initially. If this is at rest, means, my dear NEET aspirants, the block is not falling down. Why isn't block falling down? Because of the friction. Friction is holding this block. So can I say in this particular case, friction has to be equal to mg sine 30? Absolutely, sir. Why? Because then only the block will remain at rest. Friction, if upward force is equal to downward force, then the block will remain at rest, my dear NEET aspirants. Yes, I can say it something like that. Then the whole assembly is moved up with constant velocity 4 meters per second. Whole assembly means this. It says that it is moved up with constant velocity 4 meters per second. Okay. With 4 meters per second in the upward direction. The work done by frictional forces, we are supposed to find what is the work done by frictional force. Okay. What is the work done by frictional force in time 2 seconds? Listen to me very carefully. Sir, work done simply means frictional force into displacement into cos of theta. This is how we find the work done by friction. Now the point here is, if you are supposed to find work done by the friction you will calculate from here. But how do you find the displacement? See, first find friction. M is 1, G is 10, sine 30 is 1 by 2. So this will come out to be 5 Newton. Friction we got. Now guys, velocity is given. This is velocity. And time is given. So if this is the velocity and you have time, you can find displacement. So displacement is equal to velocity into time. In 2 seconds, how much displaced it will be? How much will be displaced? So what is velocity? That is 4, time is 2. So this will come out to be as 8 meters. Now boys and girls, listen to me very carefully. On this block, this is the direction of frictional force. And this is the displacement in the upward direction. And this angle is given over here 30 degrees. You can clearly see this is 30. How much will be this? This will be 60 degrees because total is 90. Now, what is the angle between frictional force and displacement? That is 60. So we'll be saying work done is equal to frictional force is how much? That is 5. Into displacement is 8. Into cos of 60. Cos 60 is 1 by 2. So this will be 40 into 1 by 2. So work done in this particular case will be 20 joule. Sir, this is done and dusted. Please tell me in the chats if this is clear. Please tell me in the chats if this is clear. Guys, smash the like button if you have not liked the session yet. Quick. Smash the like button if you have not liked the session yet. Quick. Tell me in the chats with the fire emojis if this is crystalline clear. Quick, guys. Take a look at this question. JEE 2026. JEE 2026. Hey, this is simple, bro. This is simple, bro. There is a block over here which is at rest. So it is at rest because friction is balancing mg sine theta. Arey, it is simple, bro. Okay, friction is balancing mg sine theta. That's why it is not falling down. Then it says that we are lifting the entire system in the upward direction. Whenever there is, see. Whenever there is force and there is displacement, there will be work. Don't tell me here, sir, friction is not displacing the block, how it is going to perform the work. Bro, whenever there is force and there is displacement means work is there. As simple as that. So force is friction because we have to find the work done by frictional force. Force is friction. And displacement, when you displace this block in the upward direction, how much displacement, sir? That is velocity into time, 8 meters. Now force is in this direction, displacement in this direction, angle is 60. So that is Fs cos theta. It is simple, bro. Now, a body of mass 1 kg moves along a straight line. V is equal to, this is the velocity. There is a body. It is having the velocity V is equal to 2x square. Okay. It moves from this point to this point. So from x is equal to 0, here x is equal to 0, here x is equal to 5 meters. Okay. Guys, could you please tell me what is the initial velocity by the way over here? Sir, initial velocity is when x is equal to 0, put x is equal to 0, velocity will be 0. Final velocity is, put x is equal to, my dear NEET aspirants, 5. So 5 square is 25. 25 into 2 is 50. 50 meter per second. Absolutely, sir. Now you have to tell me how much is the work done. See, whenever you see final velocity, initial velocity, something like this, apply work energy theorem. So you can say as work done is equal to kinetic energy final minus kinetic energy initial. Kinetic and work energy theorem. So work done in this particular case will be 1 by 2m V final square minus V initial square. Now mass of the block is given. So you can simply say in this particular case, this will be 1 divided by 2. Mass is 1. V final square, that is 50 square. Okay, minus initial square, that is 0. So this will be 2500 divided by 2, that is 1250. Is this clear? Is this clear? Is this clear? Give me the signal in the chats. JEE 2026 question. 6th April. What is the today's date? 6th April. What is the today's date? Today's date is 11th April. This was asked in 6th April. JEE 2026. Okay. This 5th April. This question. Okay. Again the question from 6th April. JEE 2026. 6 days back. This question was asked in 6 days. Asked 6 days back. Mass is 1 now. 1 kg, bro. Now, guys, take a look. This is a good question. This is a very good question. The raindrop of mass 1 gram starts with 0 velocity. Okay. The raindrop of mass 1 gram starts with 0 velocity from height h. This is a raindrop. It starts with 0 velocity, means initial velocity is 0. Okay. 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 And its mass is 1 gram. 1 gram means 1 divided by 1000. 1000 kg. 1 gram is how many kgs? 1 divided by 1000 kgs. Then, my dear NEET aspirants, it says that it hits the ground. Okay. With 0 velocity from height 1 kilometers. Okay. From 1 kilometers, it hits the ground. Here it is going to hit the ground. Here it is going to hit the ground. Okay. And this height is 1 kilometers. 1 kilometer means 1000 meters. With a speed of 5 meters per second. Here final speed is 5 meters per second. Now it says that the work done by resistive force. Guys, see. When this was falling, what is the force acting in the downward direction? That is mg. And what is that one thing which is resisting it in falling down? That is friction, air friction. resistive force. Okay, so resistive force is basically applying a kind of resistance to this so that it does not fall down. Yes, sir. Now, guys, we say as. Listen to me very carefully. Work done by all the forces. We write gravity is here, work done by gravity or work done by conservative force plus work done by resistive force. It will be equals to change in kinetic energy. Array, apply kinetic energy theorem. Work energy theorem. Yes, sir. Now, work done by mg. First of all, let's find work done by mg. That is force into displacement into cos theta. Now, tell me, what is force? That is mg. What is displacement? That is h. How much it has displaced from top to bottom? H. Cos theta. mg is in the downward direction, force. Displacement is also in the downward direction. What is the angle between the two? 0. So cos 0 is 1. So what is the mass over here, my dear NEET aspirants? 1 divided by 1000. What is the value of g, guys? That is 10. What is the value of height, guys? That is 1000 again. Cos 0 is 1. So 1000. So this will come out to be 10 joules work done by this. Work done by mg. Now, my dear NEET aspirants, can I say in this particular case, let's find change in kinetic energy. So I can say delta Ke will be simply kinetic energy final minus kinetic energy initial. So that will be 1 by 2 mass into V final square minus V initial square. Absolutely, sir. That will be equals to 1 divided by 2. What is the value of mass? Mass is 1 gram. That is 1 divided by 1000. Okay. And V final square. Final is, we say 5 square. That is 25. Final is 25. And what is initial? Initial in this particular case is 0. Okay, initial in this particular case is 0. Now, if you solve this, my dear NEET aspirants, 25 divided by 2000, this will be 0.0125 joules. Now, what can I say? Work done by mg. Work done by mg plus work done by resistive forces will be equals to delta Ke. Now, this comes out to be 10 plus this one. Work done by resistive force is equal to, this is 0.0125. Now take it over there. So work done by resistive force will come out to be 0.0125. Then we say minus, I would say 10. Is this clear? It will come out to be minus 9.98. Minus 9.98. Minus 9.98. Let's move on to the next one. Take a look, my dear NEET aspirants. This is the question which was asked in the recent attempt. See the question. An object is projected with kinetic energy. An object is projected with the kinetic energy K from point A. An object is projected from this point A with kinetic energy K. Could you please tell me what is the initial kinetic energy if I write over here? That will be 1 by 2 mv square. 1 by 2 mv square. I can say something like that. Okay, this is initial kinetic energy. And my dear, because shear velocity is V. Okay. My dear NEET aspirants, when it reaches the topmost point, we know that at topmost point of a projectile, vertical component is 0. This also I have told you in the last session. If you remember, in the last session, I covered this also. And horizontal component at topmost point, even throughout the motion, horizontal component, it remains, that is V cos theta only, V cos of 60. Guys, if this is V, how much will be this? This will be V cos 60. So whatever is the horizontal component of projectile here, same will be here, at every point it remains same. So this will be cos 60 is 1 by 2, that will be V divided by 2. Okay. Now, if I say, my dear NEET aspirants, this is the mass m at topmost point. It says the ratio of difference in kinetic energy at point B and point C and point A. The ratio of difference in kinetic energies at point B and C to that of A in the absence of air friction is we are supposed to find what is the ratio of kinetic energy at point B and C to that of A. B and C to that of A. Okay. Now in this particular case, I'll just give you the idea over here what you guys are supposed to do. See, if I say what is the kinetic energy at this point? What is the kinetic energy at this point? Sir, that is K. This kinetic energy is given as K. Okay. Then if you find the kinetic energy at this particular point, my dear NEET aspirants, listen to me very carefully. I'll just give you the general idea and we'll move. At this particular point, what is going to be the kinetic energy? This is kinetic energy at A, kinetic energy at B. So you'll be saying, sir, 1 divided by 2, mv square, mv square. Sir, this is m. And what is this v? Is this v speed or velocity? This v is, I would say, speed, not velocity. So at this point, this v here is speed. You don't have to write this velocity because kinetic energy is scalar quantity. So what is the net speed at this particular point, topmost point? That is v divided by 2 whole square. Okay. So my dear NEET aspirants, I would say over here, take a look. This will be 1 divided by 2m v square divided by 4. So 4 into 2 is 8. Now, if you ask me, see, if you have launched an object with velocity uv, it will strike the ground with the same velocity v, So mass is m. So my dear NEET aspirants, can I say kinetic energy at point C? It will be again 1 by 2m v square, and this will be also K. This will be also K. So here it is coming out to be how much? Here it is coming out to be K. Here also it is coming out to be K. So what can you write? What can you write, my dear NEET aspirants, at this particular point? So this will be 1 by 4 of this. So 1:4 will be, if you find the ratio between this and this, this and this. Is this clear? Is this clear? Because here also and here also kinetic energy will be same. So at this particular point, kinetic energy will be what? This you can write as 1 divided by 4 of, I can say 1 by 2 mv square. So 1 by 2 mv square is K. Okay. Okay. So this will be K divided by 4 over here. That is 1 divided by 4. Okay. Let's move on to this one. JEE 2026. JEE 2026. Take a look at this question, guys. Take a look at this question, guys. Be fast. A body of mass 2 kg is moving along x direction such that its displacement is a function of time. Okay, displacement is given as, that is alpha t square plus beta t plus, I would say, gamma. Value of alpha is given over here, value of beta is given, value of gamma is given. The work done on the body during the time interval t is equal to 2 to t is equal to 3. Guys, listen to me very carefully. Listen to me very carefully. If displacement is given, how do you find velocity? That is dx by dt. Sir, why are you finding velocity? Because I know one thing. Work done is equal to change in kinetic energy. So work done is equal to 1 divided by 2, mass is m. So final kinetic energy minus initial kinetic energy. Sir, how do you get to know that? You are supposed to apply the kinetic energy theorem over here, because I saw mass and I saw displacement over here, because from displacement we can find velocity. Now guys, can I write over here, guys? Do the differentiation of this. 2 into alpha means 2 alpha t plus, what is the differentiation of beta t? It is beta, because alpha and beta are constants. 1, 2, 1, 1, 1. And for this gamma constant, it is 0. This is velocity. Now, my dear NEET aspirants, if this is velocity, can you tell me over here? What is initial velocity? Initial velocity is when time is 2. Final velocity is when time is 3. So put 2 over here. So this will be 2 alpha into 2 plus, I would say, beta in this particular case. Okay. Yes. Now guys, tell me, initial velocity is, I would say 4 alpha plus, I would say, beta. 4 alpha plus, I would say, beta. Now guys, you can say initial velocity is 4 into, what is the value of alpha, guys? 1. What is the value of beta, guys? That is 1. So this is 1 plus, I would say, 1. So V initial will come out to be 4 and 1 is 4, 4 plus 1 is 5. Let's talk about final velocity. Final velocity is put t is equal to 3 over here. That is 2 alpha into, I would say, 3 plus, I would say, beta. So this will be 2 into 3 is 6 alpha plus beta. So this would be over here 6 into 1 in this particular case, plus I would say over here, this is also 1. Okay, so this would come out to be 7 meter per second. Now, boys and girls, tell me, what is the work energy theorem? 1 divided by 2. Mass over here is 2. Okay. Final velocity, that is 7 square, minus initial velocity, that is 5 square. Okay. This and this will cancel. This will come out to be 49 minus 25. Is this clear? Oh? Is this clear? Give me the signal in the chats if this is crystalline clear. Give me the signal in the chats if this is crystalline clear. Come on, quick. Let me know in the chats. And smash the like button if you are not liked the session yet. Come on, do it. I'll provide you the questions in the form of DPP later on. Manoj, later, bro. Chill. Now, guys, let's define power. Power is what? Power is simply rate of work done. Okay? Rate of work done. Work done with respect to time. Okay? Listen to me very carefully. How do you define what is the rate of work done? With what rate you are able to perform work? Like, let's suppose there is a person A. He is performing, let's suppose he is doing some sort of work. This is a person B. This is person A, this is person B. Both are performing work, displacing the block, whatever it may be. This person is taking 2 seconds. This person is taking 10 seconds in performing the same work. Who is having more power? A is having more power as compared to B. That's what we say. How fast you are able to do the work. If you have 2 machines, this has bigger, large horsepower. This has less horsepower. Why? Because this machine is able to perform more work in less time. This machine is able to perform less work in more time. That's why this has got more power, this has got less power. This is how we define power. With what rate you are performing the work done upon time. How fast you are performing the work done, that is how you define power. Now, guys, so we write this power something like this also. This power is equal to, average power is equal to delta W divided by delta T. Total work done upon total time. This is average power. And instantaneous power. Instantaneous power. We write it like this also. That is dW divided by dt. Guys, this is the power at a particular instant. Okay. This is a power at particular instant. Like if you are displacing an object from here to here, you did delta W work in how much time? Delta T. So total work done divided by total power is, total work done divided by total time is average power. If I say, sir, how much power you were applying here when you did small work done for small time. That is instantaneous power. If you displace the body from here to here, you are applying large power. If you displace the body from here to here, means you are doing little work. So means in that particular case, you are doing, that is how we define it as instantaneous power. Okay. Now, boys and girls, even you can write it like this also. Power is equal, instead of work done is change in kinetic energy. You can write it like this also, delta KEW divided by delta T. These are all the formulas of power. Now, in terms of force and velocity, so my dear NEET aspirants, you say power is force F dot V. Like dot product of force and velocity is power. That is FV cos theta also. FV cos theta also, that's how we define power. Where theta is the angle between force and velocity. For a system with varying mass, if there is a mass, like this, there is a rocket. While the rocket is going up, its mass decreases. If the mass is constant, we say we apply these formulas. If the mass is variable, in that particular case, we say V square dm by dt. Dm by dt is the rate of change of mass. Dm by dt, this is a rate of change of mass. Sir, if the rocket goes up, how much power is developed in the rocket? We use this formula because over there mass is changing. I hope these formulas are crystalline clear. Let's talk about this question first. NEET 2023. A particle moves with a velocity of, this is the velocity of the particle, that is 5I cap minus 3J cap plus 6K cap. Okay. Horizontally, under the action of the constant force, this is the force acting on the particle, 10I cap plus 10J cap plus 20K cap. The instantaneous power supplied to the particle is, guys, when you have force and velocity in vector form, you simply say power is F dot V. F dot V without a shadow of doubt. How do you do the dot product of two vectors? Coefficient of this multiplied by coefficient of this. So 10 into 5 plus. So do we have to write I cap also? No. 10 into minus 3. 10 into minus 3, I can write it something like this. 20 into 6 plus 20 into 6. Now solve this, my dear NEET aspirants. So this will be the power. This will be the power. Take a look at this question. This is a question from J Mains 2025. This is a question from J Mains 2025. Now guys, listen to me very carefully. An object of mass 1000 grams experiences a time-dependent force. This is the force acting on the particle. This is the force acting on the particle. The power generated by the force at time t is, okay. Guys, this is the force. Force is given as, that is 2ti cap plus 3t square j cap. Sir, force is given, mass is given. How do we find the power? Guys, can you find acceleration from the force? Yes, I can do that, sir. Sir, from acceleration, I can find velocity also. Yes. So let's do that. So acceleration is force upon mass. This is the vector form upon mass. Now tell me, what is force over here? Force is, this is 2ti cap plus 3t square j cap divided by, how much is the mass? Mass of the object is 1000 grams. 1000 grams means 1 kgs. It's 1 kg divided by 1. So this is the acceleration vector. That is 2ti cap plus 3t square j cap. Now from acceleration, how can you calculate velocity? I have told you this also. Sir, that is delta v is equal to integration of a dt. So from now onwards, you remember it directly. If acceleration is given, you are supposed to find change in velocity. You will be using this. Okay. Absolutely, sir. Now, boys and girls, listen to me very carefully. An object of mass experiences time-dependent force. So force is acting on the object. So means when time t is equal to 0, this term would be 0, this term would be 0. So at time t is equal to 0, force is 0. So if no force is acting on the object, will the object move? No. Means initially the object is at rest. So this I can write final velocity minus initial velocity. Initial velocity is 0. Because time dependent force is acting. If you put time is equal to 0, force will be 0. Velocity will be 0. Because it is moving due to the force only. Now boys and girls, I can say integration of acceleration, that is 2t I cap plus 3t square j cap dt. Now what can I say in this particular case? Initial velocity is 0. So final velocity is v. So I can say, what is the integration of this? This will be 2t square divided by 2 plus. What is the integration of this? That is 3t cube divided by 3. Okay, something like this. Now, my dear NEET aspirants, v is equal to this and this will cancel, this and this will cancel. This would be over here, t square plus t cube. And mention over here this also. This is I cap, this is j cap. I cap, this is j cap. Now, if you got velocity and if you have force, how do you define power? Power is F dot V. So power in this particular case is F dot V. F is this. Now dot product of two vectors. So 2t is the coefficient here. Here it is 2t square. So 2t into I would say t square plus. What is the coefficient over here? That is 3t square into I would say t cube. Now this power will come out to be 2t cube plus 3t raised power 5. 2t cube plus 3t raised power 5. Option C. Is this clear? Oh? J mains 2025. J mains 2025. Is this clear? Please tell me in the chats quickly. A sand dropper drops a sand of mass m on a conveyor belt at a rate proportional to the square root of the speed of the belt. So dm by dt in this particular case is given. It is proportional to root v. If the power delivered to run the belt at a constant speed, then which of the following relations is true? Guys, see. A sand is sand dropper. Sand dropper means which drops the sand on the conveyor belt. You can basically search it on Google also. What is this sand dropper? How does it actually look like? So sand dropper drops the mass on the conveyor belt at the rate of, at a rate proportional to the square root of the speed. In short, this is dm by dt is given to this. Which of the following relations is correct? We have to see. See. Can I say, as we recently studied, power is equal to v square dm by dt. When I saw this particular question, I immediately got this equation in my mind. Now, what is the value of dm by dt? That is root v. So p is equal to v square and this is root v. Instead of this, I can write root v. So p will be equals to v square. Root v means v raised power 1 by 2. Okay, because value of root is 1 by 2. 1 plus 1 by 2 is 2 into 1 is 2. Sorry, 2 into 2 is 4. 4 plus 1 is 5 by 2. So power will be equals to v raised power 5 by 2. Now squaring both sides. Squaring both sides. If you do the squaring on both sides, this will be power square is proportional to, guys, here if you do the square and 2 will cancel. So v raised power 5. So p square is proportional to v raised power 5. Is this clear? Tell me quickly in the chat. Is this clear? Come on, guys. Oh, is this clear? Oh? Smash the like button if you are not like the session yet. Come on, quick. Make it 1000. Okay, now let's take a look at this particular question. Take a look at this. Center of mass of a rod. Guys, center of mass is simply that point where you can concentrate the whole mass. If I say you hold this rod at one point, you would say, sir, that would be the center of mass, exactly at the center. If the rod is uniform, means mass is distributed equally at every point. So this is the rod over here. When you have this rod in this particular case, listen to me very carefully. If this is the rod, okay, this is the rod. And in this particular case, I would say lambda is constant. Lambda constant means lambda is mass per unit length. Mass per unit length. Means on the unit length, whatever is the value of mass present here, same will be here. Same will be here. The amount of mass present at every single point is same. When lambda is given as constant, means guys, mass at this point is not greater than mass at this point. Mass will be same at every point. That means lambda is constant. So in this particular case, we say center of mass of the rod will be at L by 2. That is 0.5 L. Okay, at this point, it will be the center of mass. Now guys, center of mass of variable mass system. If lambda is constant, you'll be writing this is the center of mass at L by 2. If lambda is proportional to x, means lambda is proportional to x means mass is varying linearly. So here it is more mass. As you move towards the right, we say mass increases. So from the right side, rod looks bit heavier as compared to the left side. So in this particular case, my dear NEET aspirants, center of mass will shift towards the large mass. So it will be at 0.6 L. When lambda is constant at 0.5 L. When lambda is proportional to x at 0.6 L. When lambda is proportional to x square, it will be at a 0.75 L. And when lambda is proportional to x cube, it will be at 0.85 L. This is very, very important. Like you have a question, the density of the thin rod of length L varies with the distance x from one end as this. This is the density given. What is the relation in this particular case? Lambda is proportional to x square. So shortcut I'm going to apply. Center of mass will be at 0.75 L, which I told you here. 0.75 L here. 0.75 L. Even if you do the normal method also, so answer will still come out to be the same. But what I told you to remember the shortcut, lambda is proportional to x square, directly 0.75 L. This is the normal long method. You can see it from your end. Is this clear? Is this clear? Tell me guys, quick. Is this clear? Give me the signal in the chats. Is this clear? Is this clear? Now guys, let's understand the concept collisions. Collision means when two objects strike, like these are the two objects moving with certain velocity, they strike. When they strike, then they again start moving with certain velocities. That is how we define collision. When two objects strike, after the collision, they again move. Before the collision, they were moving. So this is how we define collisions. So first type of collision is elastic collision. I would want you guys to listen to me very carefully over here. Listen very, very, very carefully. Elastic collision. We say it is that collision after which two objects regain its shape and size. Like before the collision, This is the mass m, ball, one ball of mass m moving with velocity u1. This is another mass m2 moving with velocity u2. When they collide, this is during collision. When they collide, they get deformed. See, some deformity takes place, okay? The two balls will be deformed. But after the collision, the two balls will regain their shape and size exactly. This is how we define an elastic collision. Okay. It also regains its kinetic energy, which was converted to potential energy during the collision. So, my dear NEET aspirants, whatever is the kinetic energy of this system initially, after the collision, they will be having the same kinetic energy, because that is what happens in the elastic collision. Two balls collide, they are deformed. After the collision, they will regain their shape and size again. This is elastic collision. Kinetic energy will be also regained. And this E is called coefficient of restitution. This is 1. You'll get to know after some time what this actually is. Coefficient of restitution for elastic collision is 1. Now, what is this V2 minus V1? Guys, see. What is the velocity here? V2. This is moving with V2. This is moving with V1. This is after the collision. So means this is that velocity with which they are separating. So V2 minus V1, this is called velocity of separation with which these two masses are separating. Now this U1 and U2, with these two velocities, they are approaching. So this is called a velocity of approach. U1 minus U2 is velocity of approach with which the two masses approach. V2 minus V1 is velocity of separation. And we say this V2 minus V1 upon U2, U1 minus U2, velocity of separation divided by velocity of approach, it is equal to coefficient of restitution. And coefficient of restitution for elastic is 1. So if you put 1 here, you will take it here. So we say velocity of this separation is equal to velocity of approach. So my dear NEET aspirants, in case of elastic collision, whatever is the velocity of approach, same is the velocity of separation. Means with what velocity they are approaching with each other, same velocity they will be separating from each other. So kinetic energy before the collision is equal to kinetic energy after the collision. This also I told you. You have to remember these, my dear NEET aspirants. Momentum is also conserved. What is the momentum? Guys. What is the momentum here? Momentum is mass into velocity. That is m1 u1. Plus, what is the momentum here? m2 u2. So this momentum will be equals to, what is the momentum here? m1 v1 plus I would say m2 v2. So momentum also is conserved in this particular case. Now guys, if somebody says that two masses are colliding elastically, velocity initial is u1, here it is u2. What will be the final velocity v1? What will be the final velocity v2? This is the velocity v1 after the collision. m1 minus m2, this you have to remember, sorry. Divided by m1 plus m2 into u1 plus 2 times of m2 u2 upon m1 plus m2. This is the velocity of m1 mass after the collision. And this is the velocity of m2 mass after the collision. Give me the signal in the chats. Then we will move on to the inelastic collision. This is very important. Give me the signal in the chats if this is crystalline clear. Come on, guys. Give me the signal in the chats if this is crystalline clear. Come on, everybody of you. And make sure you smash the like button. Make sure you smash the like button. Come on. Give me the signal in the chats. Everybody. Okay. Now, guys, listen to me very carefully. Inelastic collision, it is that collision in which the two objects does not regain its kinetic energy. It is that collision in which the deformation takes place due to the kinetic, to which kinetic energy is changed to the potential energy. Means, in nutshell, after the deformation, masses does not regain their original shape and size. In case of inelastic collision, when the two masses collide, you see, deformed mass, deformed. It is not exactly like the spherical mass before, like it was before. So we say when deformation takes place, it does not regain its shape and size. That is inelastic collision. Even here, kinetic energy is not regained. Whatever is kinetic energy initially, same is not the kinetic energy finally. And coefficient of restitution here is greater than 0, less than 1. It was between 0 and 1. It is between 0 and 1. Now, boys and girls, in case of inelastic collision, momentum is conserved. Yes, momentum is conserved in all types of collisions. In elastic, in case of elastic collision, kinetic energy initial, kinetic energy final. Velocity of separation is equal to velocity of approach. Momentum initial is equal to momentum final. But here, kinetic energy initial is not kinetic energy final. Okay. And here, momentum is same. Momentum is conserved. Whatever is the momentum initially, same will be the momentum finally. Okay, m1 u1 plus m2 u2 upon this and this. And if I, let's suppose, say, my dear NEET aspirants, let's suppose coefficient of restitution is 0.5. Because it is between 0 and 1. So put it 0.5 over here. 0.5 means 1 by 2. And coefficient of restitution means v2 minus v1. Velocity of separation upon velocity of approach. So v2 minus v1 upon u1 minus u2. This is 1 by 2. Now take it here. So v2 minus v1, velocity of separation is equal to 1 by 2 of u1 minus u2, velocity of approach. So velocity of separation is half of the velocity of approach. So whatever the velocity they were approaching with, afterwards, velocity will become half. Velocity is decreased. So velocity of approach is not equal to velocity of separation. Velocity of separation is less than velocity of approach because it is half. So kinetic energy final is less than kinetic energy initial. Kinetic energy is final. Kinetic energy final is less than kinetic energy initial. And this is the velocity, guys. This is the velocity of m1 after inelastic collision. Okay, and when it comes to this, boys and girls, this is the velocity of m2 after inelastic collision. And my dear NEET aspirants, consider these two as general expressions. See, consider these as general expressions. Wait, I'll tell you what. First, let's complete perfectly inelastic. Perfectly inelastic collision is that collision. It is that collision in which two bodies stick to each other after the collision. This mass m1 and m2 are approaching. While they collide, after the collision, they stick together and move together. So when they stick together and move together, whatever is the velocity of this mass finally, same will be this mass finally, and we call that v. Why? If they stick to each other, whatever is the velocity of first mass, that will be velocity of second mass because they are moving together. So v2 is equal to v1 is equal to this. And in this particular case, kinetic energy is not conserved. Momentum is conserved because I told you momentum is conserved in all the cases. Kinetic energy initial is not equal to kinetic energy final. And my dear NEET aspirants, if somebody says, what is the velocity of this system finally after the collision in case of perfectly inelastic? m1 u1 plus m2 u2 upon m1 plus m2. This is the velocity of masses after the collision, after inelastic collision. Now, what did I tell you? Consider these two as general expressions. And for this inelastic collision, my dear NEET aspirants, For this inelastic collision, I would say coefficient of restitution we consider as 0. So we say consider these two general expressions. We say for inelastic, guys, in this expression put the value of E is equal to 1. For elastic. For perfectly inelastic, put E is equal to 0. When you put E is equal to 0 over here, you'll be getting the velocity. You'll be getting this velocity. And when you will be putting E is equal to 1, you'll be getting this velocity and this velocity. Please tell me in the chats if all the three types of collisions is crystalline clear. If all the three types of collisions is crystalline clear. Guys, I need the signal in the chats because I have told you every single thing in a detailed manner. Please let me know in the chats if all the things are crystalline clear. Everyone means everyone. Come on, guys, tell me, is this clear? Is this clear? Absolutely. Okay, now guys, loss in kinetic energy. This is very important. Loss in kinetic energy. In case of elastic collision, we say whatever is the kinetic energy initially, same is the kinetic energy finally. So kinetic energy initial is equal to kinetic energy finally. What will be lost? 0. In case of inelastic collision, kinetic energy initial is not equal to kinetic energy final. Okay, so we say loss will be here. Loss in kinetic energy is 1 by 2 m1 m2 upon m1 plus m2 into u relative square into 1 minus E square. E is the coefficient of restitution. For this, E is equal to, E is between 0 to 1. And U relative means that is U1 minus U2 before the collision. This is U1 minus U2. For perfectly inelastic, how do you find the loss? 1 by 2 m1 m2 upon m1 plus m2 U relative square. Again, U relative is U1 minus U2. Its whole square. This is how do you find the loss? Very, very important expressions, my dear NEET aspirants. Let's first talk about this question over here. Let's see this particular question. What does the question say? A ball of mass 4 kg moving on a smooth horizontal surface makes an angle, makes an elastic collision. It makes an elastic collision, okay? With another ball of mass m at rest, if after the collision, first ball, this ball which is moving with velocity u, and another ball is at rest, it is 4 kg, this has mass m. After the collision, if after the collision, first ball moves with 1/4 of its velocity, this first ball moves with 1/4 of its velocity. And mass of the second ball will be, you guys are supposed to tell me what is the mass of the second ball. This is given. Now, boys and girls, can you tell me in this particular case, it says elastic collision. It says elastic collision over here. Guys, can I say as in case of elastic collision? How do we write the velocity? Could you please tell me how do we write the velocity? In case of elastic collision, how do we write the velocity? This is the velocity in case of elastic collision. m1 minus m2 into u1. Okay, m1 minus m2 into u1. I'll be writing it over here. We say m1 minus m2 into u1 upon m1 plus m2. Okay, then what is the next expression? This is what you guys are supposed to remember, my dear NEET aspirants. 2 times of m2 u2 plus 2 times of m2 u2 upon m1 plus m2 upon m1 plus m2. Let me check this expression. Okay. m1 minus m2 into u1 upon m1 plus m2 upon plus 2 times of m2 u2 upon m1 plus m2. Yes. Now, boys and girls, what I want you to understand in this particular case, if u2 is 0, it says second mass is at rest. So means this term would be 0 because u2 is 0. So this entire term would be 0. What is the value of v1? This is the value of v1 because it says first mass moves with velocity 1/4 of its velocity. So this will be u by 4. U divided by 4 will be equals to. And this m1 minus m2, that is 4 minus m into u. What is the velocity initially? That is u divided by m1 plus m2, that is 4 plus m. So u and u will cancel. Take it over there. So further you can write, take it over there. So this will be 4 plus m is equal to 4 into 4 is 16 minus 4m. Take it over there, take it over here. So this will be 4m plus m is 5m is equal to 16 plus 4 is 20. 16, this will be minus 4. 16 minus 4 is 12. M will be 12 by 5. This is u by 4. This is 4 plus m. 16 minus 4m. So 4, if you take this, what did I do? What did I do? Okay, take this over here. This will be 5m. 4m, it will go 5m, and this will be, yeah, correct. 16 minus 4, that is 12. M is equal to 12 by 5. Is this clear? Oh? Tell me in the chats, everybody out there. Is this clear? Come on. Is this clear? Clear or tell me? Shall we move on to the next? Why is somebody saying 6 kg? Oh? How 6 kg? V1 is u by 4. V1 is u by 4. M1 minus M2. M1 is 4, M2 is M. So 4 minus M into V1. This is u. That is u1 over here. u1 is u. This is u. Divided by m1 plus m2. That is 4 plus m. U and u will cancel. So this 4 plus m will go here. 4 into 4 is 16 minus 4m. So this is m. If you take this m over here, 4m plus m is 5m. If you take this over there, 16 minus 4 is 12. 12 by 5, na? 12 by 5, na? Is that correct? Okay, let's talk about this one. Two masses 4 kg and 8 kg collide with each other. And the collision is perfectly inelastic. This is a perfectly inelastic collision. Find the velocity of the masses after the collision. Guys, this mass and this mass, they are colliding with each other. This is the diagram given in the question. Perfectly inelastic. Perfectly inelastic. Okay. Now, if this is a perfectly inelastic collision, what is perfectly inelastic? They stick to each other, then move with the common velocity. They stick to each other, then move with the common velocity. They stick to each other and then move with the common velocity. Now, what is that common velocity? How much is that common velocity? M1 U1 plus M2 U2 upon M1 plus M2. Okay. That common velocity is M1 U1 plus M2 U2 upon, I would say, M1 plus M2. Something like this I can say. Now, this velocity is M1 U1 What is the value of M1, my dear NEET aspirants over here? M1 is given as 4. M2 is 8. So this is 4. And U1, velocity of this is 8. Then plus M2 is given as 8. U2 is given as, guys, shall I consider this as plus 4 or minus 4? Minus, because it is moving in a left direction. So minus 4. Divided by M1 plus M2. M1 is 4, M2 is 8. 8 plus 4 is 12. So this we will come out to be 8 4s are 32, and this will cancel now, because this is minus 32 plus 32. So final velocity in this case will be 0. Finally, the two masses will come to rest. Finally, the two masses will come to rest. Okay. An object of 80 kg mass moving with velocity 2 meter per second. An object of 80 kg mass moving with velocity 2 meter per second. Collide with another object of mass 20 kg. It collides with another object of mass 20 kg. Moving with 4 meter per second. This is moving with 4 meter per second. Find the energy loss if you consider this as perfectly inelastic. Guys, how do you find the energy loss in case of perfectly inelastic? 1 by 2 M1 M2. So I would say kinetic energy loss 1 divided by 2 M1 M2 upon M1 plus M2 into U relative square. So this will be 1 divided by 2 M1 M2. Mass of first is 20. Mass of second is 80 divided by first is 20 plus 80, that is 100, into U relative square, that is 4 minus 2, its whole square. Now 0 0 0 0, 2 and 2 will cancel. This is 8. Okay, this is 8. 4 minus 2 is 2. 2 square is 4. So 8 into 4, that is 32 joules. 32 joules. Is this clear? This I am giving you as homework. Its answer is mentioned over here. Please do check this. Okay, what is the question saying over here? Do check this from your end. You can take the screenshot also. This question also I am giving you as homework. Please do check this question also from your end. This is a previous year question of JEE Mains. One more important thing over here. This is also important. This is also important. Is this clear? Or tell me in the chats, everybody out there. Is this clear? Okay, now guys, what does the question actually say? Take a look. A body of mass m, guys, smash the like button if you have not liked the session yet. A body of mass m falls from height h on the ground. This is the body of mass m. It falls from height h on the ground. This is the ground. If E is the coefficient of restitution between the body and the ground, then the distance traveled by the body before it comes to rest. Amazing question. Take a look. Body falls. Then we say collision takes place. Again, it rises up to certain height. Again, it falls. Again, it rises up to certain height. Again, it falls. Again, it rises up to certain height. Again, it falls. Rises certain. After some time, my dear NEET aspirants, it will come to rest. It is like this. It falls, then it rises up to certain height. It falls, then again it rises certain height. It falls, again it rises certain height. Here it comes to rest. And if they ask you how much distance it is going to cover before it coming to rest, from here to here, how much is this distance, this length? So this is the total distance covered. Total distance. Total height you say, or total distance you say. That is this h. H is this h. Then we say into 1 plus e square upon 1 minus e square. Directly remember. Directly remember. Okay. Okay, you don't have to derive it directly. Okay. Okay, if somebody says how much time it is going to take before it comes to rest, sir, time 2 seconds, 1 second, 1.5 seconds, something like this. How much time it is going to take before it comes to rest? Okay, time taken before it comes to rest. Okay, so time taken is under root of 2h by g, 1 plus e into 1 minus e. H is the height, this height from which it is falling initially. I hope this is crystal and clear. You have to remember this expression directly. Okay, one more important thing. Guys, collisions is very, very important. You can expect 100% 2 questions from this. That's why I'm showing you these. Velocity and height after n collisions. Listen to me very carefully. Velocity and height after n collisions. Now see, if an object falls, initial velocity is equal to 0, it is dropped, it falls height h. Then it is basically again rising up to certain height. This is what we call height after first collision. This is what we call height after first collision. Then again it falls. Then again it rises. This is called height after second collision. Again it falls. This is called height after third collision. Again it falls. This is called height after fourth collision. Similarly, what is the height after n collisions, my dear NEET aspirants? Directly remember. Height after nth collision. E raised power 2n HBC. What is HBC? That is height before the collision. This one. HBC is the height before the collision. Before it collided the surface, this was the actual height. So this is height after nth collision. So this is the height after this nth collision. Sir, if you have to find height after first collision, so you'll be putting value of n is equal to 1. This one. Height after second collision, you'll be putting value of n is equal to 2. Height after 10th collision, you'll be putting value of n is equal to 10. Similarly, if somebody says, what is the velocity after nth collision? Guys, ball falls, it strikes. This again rises. This is the velocity after it strikes the surface. This is velocity after first collision. Then again it falls. Then again it rises. This is velocity after second collision. Then again it falls. Then velocity after third collision. Similarly, velocity after nth collision. E raised power n. Velocity before collision. This is velocity before collision. And let me just tell you, my dear NEET aspirants, my dear amazing NEET aspirants, velocity before collision is under root of 2gh. Whenever an object is dropped, with what velocity it strikes the surface, that is called velocity of hit, that is under root of 2gh. So this is velocity after nth collision, my dear NEET aspirants. AC means after collision, BC means before collision. Is this clear? Please tell me in the chats. Is this clear? Please tell me in the chats. Okay. Let's take a look at this question. This is a question of NEET 2025. Is this clear? Smash the like button if you are not like the session. Come on, quick. Make it fast. Boys and girls, ladies and gentlemen. Okay. A ball of mass 0.5 kg is dropped from a height of this. Okay, one more important thing, guys. Coefficient of restitution is also equal to this under root of height after the collision divided by height before the collision. Keep this thing in your mind. This is the coefficient of restitution. This is how we define the coefficient of restitution. Okay, height after the collision divided by height before the collision. Now, guys, a ball of mass 0.5 kg is dropped from a height of 40 meters. This ball is dropped from a height of 40 meters. It falls from a height of 40 meters. This h is 40. Okay. The ball hits the ground and rises to the height of 10 meters. After hitting the surface, it rises to a height of 10 meters. Okay. This is, I would write over here, height before the collision. This is HBC. And this is h after the collision. This is 10. Okay. Okay, before this, okay, the impulse. Impulse means change in momentum. Leave change in momentum. Tell me, what is the value of coefficient of restitution? Coefficient of restitution means under root of height after collision divided by height before collision. Under root of height after the collision, that is 10. Height before the collision, that is 40. That is 1 by 4. That will be 1 by 2. Array, root 4 is actually 1 by 2, na? 1 by 4, root is 1 by 2 because root 4 is 2. 1 by 2. So coefficient of restitution comes out to be 0.5. If it is 0.5, which collision is it? Perfectly elastic, perfectly inelastic, or inelastic? It is inelastic collision. Inelastic collision. Okay. Now, my dear NEET aspirants, what does it say? The impulse imparted to the ball during the collision means when the ball strikes the ground, it was, what is impulse, bro? Impulse is nothing but change in momentum. Impulse is change in momentum. Directly remember. Okay, so we say this impulse's change in momentum is delta P. Delta P is final momentum minus initial momentum. Listen carefully. So this will be, final momentum is mass into final velocity minus mass into initial velocity. So this would be I is equal to, take this mass out. Final velocity means velocity, see, initial velocity means velocity before the collision. That is UBC. This is the velocity after the collision. VAC. Or VBC, VAC. So final velocity is velocity after the collision minus this is velocity before the collision. Yes, sir. Now, boys and girls, listen to me very carefully. How can we find velocity before the collision? I recently told you this is under root of 2gh without a shadow of doubt. So under root of 2, g is 10 and height is 40. Before the collision, how much is the height from which the ball is falling? 40. So if you solve this, it will approximately come out to be 28 meters per second. Absolutely, sir. What is the velocity after the collision? What is the velocity after the collision? Velocity after nth collision. If I say velocity after first collision, so what is the value of n? That is 1, my dear NEET aspirants. So we say e raised power n into velocity before collision. This is the general formula, na? So for, I would say, velocity after collision, e raised power n. What is the value of e? That is 1 by 2. Whole raised power 1 into velocity before the collision, that is 28. 28 divided by 2, that is 14. Okay. Now, how do we write the change in momentum, boys and girls? How do we write the change in momentum? Now, what I can say, impulse is equal to mass. Okay, what is the value of mass, by the way? 0.5, that is 1 by 2. Final velocity. Final velocity, velocity after the collision, that is 14. Okay. Mass into final velocity minus initial velocity. This is 14. This is 14 minus initial velocity. Guys, I have told you this in the last session, boys and girls. If the body falls down, we consider its velocity negative. If the body goes up, we consider its velocity positive. If the body moves towards right, velocity is positive. If the body moves towards left, velocity is negative. If the body goes down, velocity is negative. If the body goes up, velocity is positive. So this you need to take as minus. So this will be minus 28. So impulse would come out to be 21. Oh, it is not 7, oh, it is 21. Is that clear? Is that clear? Is that clear, boys and girls? Tell me in the chat, so is this clear? Quick. Give me the signal in the chat if this is crystalline clear. Okay, now boys and girls, let's take a look exactly at this point. Let me finish the angular momentum in nanoseconds. Let's take a look at the angular momentum over here. Guys, see. First of all, let's talk about momentum. Let's talk about momentum. Listen to me very carefully, boys and girls. Let's be quick. Let's suppose if we have a mass m over here and it is moving with certain velocity v. Listen to me very carefully. And this is point A and this is point B. Guys, see. Can I say in this particular case, my dear NEET aspirants, with respect to point B, with respect to point A, I can say with respect to point A, this mass is moving linearly. I'm standing over here. That mass is going with respect to me, it is moving with certain velocity. It is moving linearly along the straight line. So with respect to this A, it will have linear momentum. Okay, so I would say with respect to A, it has linear momentum. And that linear momentum is P is equal to mv. Why? Because with respect to A, it is moving linearly. And with respect to B, it is moving at certain angle. Even if you cut this, my dear NEET aspirants, we say it is moving at certain angle. You say this is theta. So with respect to point B, it has angular momentum. So angular momentum means if an object is moving angularly with certain point, with respect to certain point. So that's why with respect to this point, it has angular momentum. And how do you define that angular momentum? Listen to me very carefully, my dear NEET aspirants. We say, guys, if this is r radius, means this is the r position vector. And if this is r, this will be r cos theta. And this would be r sin theta. Now, my dear NEET aspirants, when you define angular momentum, you take that component of velocity or that component of radius which is perpendicular to velocity. These two must be perpendicular. So we can write over here L is equal to mv r perpendicular, something like this, because this is the perpendicular component and this is the parallel component. This parallel component does not contribute to angular momentum because with respect to this, it is moving linearly. With respect to this, it is moving angularly. It is creating some angle. So you can say L is equal to mv r sine of theta. Mv r sine of theta. You can write it like this. This is how we define the angular momentum, boys and girls. Okay. Okay. Or you can write it something like this also. You can write it something like this also. That is L is equal to r, or it like this, r, then we say mv, then we say sine of theta. Just I'm reshuffling this in this particular case, my dear NEET aspirants. Okay. So we can say, guys, this is something like this. This is something like this. L is equal to r cross mv. Why? Because we say A cross B. A cross B is AB sine theta. R cross MV is R MV sine theta. You can write it like this. And MV is momentum. So this angular momentum, you can write it like this. R cross P also. These are all the formulas of angular momentum which you can remember. Simply, if an object is moving angularly with respect to a certain point, it will have angular momentum. That's it. So this is how we define angular momentum with respect to a point. Angular momentum with respect to a point. MVR sine theta, R cross MV, R cross P, whatever you say. Now, if there is a body which is purely rotating, guys, these are two different cases. This body is moving angularly with respect to this point. Here also we define angular momentum. And if a body is purely rotating, this rod is purely rotating with respect to this axis, it will have angular momentum. And what is the value of its angular momentum? Directly remember, in this particular case, my dear NEET aspirants, we say angular momentum in this particular case will be I into omega. I is what we call moment of inertia. Moment of inertia. And omega is angular velocity. Omega is angular velocity. With what angular velocity it is moving? Like, this is a rod. This rod has, listen to me very carefully, moment of inertia about this axis which is passing through the center, ml square by 12. So different objects have different moment of inertia. This rod about this axis which is passing through its center of mass, it has moment of inertia ml square by 12. How much will be the angular momentum? ml square divided by 12 into omega, I into omega. This is the angular momentum. Okay. Yes. Let's take a look at this. An object is projected with speed u at an angle theta with respect to the horizontal. Okay. An object is projected at an angle theta with speed u with respect to the horizontal. Find the angular momentum when the object is at maximum height. Guys, it is like this case of projectile motion. It says when the object is at maximum height, what will be the angular momentum with respect to the origin? Listen to me very carefully. At maximum height, guys, if you have launched this object with velocity u, this component of the velocity is how much? U cos theta. This component is u sin theta. And we know at topmost point, it has only one velocity component, that is u cos theta. Because u cos theta remains constant throughout the journey. Y component is 0. Now here mass is m, velocity is u cos theta. Now boys and girls, this is going to be the radius vector r. Now can you tell me, if this is radius vector r, this will be the perpendicular component of radius and this will be the parallel, this will be r perpendicular. And we have studied this r perpendicular in this particular case is h max. Absolutely, sir. This is the velocity at topmost point. This is mass and this is r perpendicular. Now guys, if you say, sir, this r perpendicular is h max, and how do you define h max? What is the value of h max, maximum height? U square sine square of theta divided by 2g. Now tell me, how do we write angular momentum? Recently we studied angular momentum. That is mvr perpendicular or mvr sine theta. mvr perpendicular we can write. L is equal to mvr perpendicular. L is equal to m. What is the value of v at topmost point? U cos theta. U cos theta. Okay. This is u cos theta in this particular case. And then r perpendicular is u square sine square of theta divided by 2g. This is the value. Okay, there is a question. This was asked in JEE 2025. Even the same question I have shown you in the last class. Okay, in projectile motion, when I was basically discussing the concepts of projectile motion. An object of mass m is projected from the origin in the vertical xy plane at an angle of 45 degrees. Okay, see, let me show you this quickly. You have launched an object. You have launched an object with velocity mass m. Okay, if the initial velocity is v0, velocity v0, and its mass is m at an angle of 45 degrees. Okay, the angular momentum with respect to the origin when it reaches the maximum height. When it reaches the maximum height, guys, we have to find the angular momentum. This, if this is v0, this would be v0 cos 45. So can I say this will be v0 cos 45 is 1 by root 2. So v0 divided by root 2. So here at topmost point also this velocity would be v0 by root 2, because horizontal component of the velocity remains constant throughout the motion. Okay. So what I can say, this is mass over here. This is v0 divided by root 2. This would be r perpendicular, or we can say h max. Tell me, velocity at topmost point we got r perpendicular is h max. And how do you write h max? U square sine square of theta divided by 2g. So r perpendicular would be u square is v0 square sine square of theta, that is sine 45, its whole square. Sine 45 is 1 by root 2. 1 by root 2 whole square is 1 by 2. So it is v0 2 into 2g. Because instead of this I am writing 1 by 2. So v0 square divided by 4g. Now boys and girls, ladies and gentlemen, tell me, what will be the angular momentum? mvr perpendicular. Angular momentum is mass. Velocity in this particular case is how much? v0 by root 2. And r perpendicular is how much? v0 square divided by 4g. So this will come out to be mv0 cube divided by 4 root 2g. 4 root 2g. Let's take a look at this. JEE Mains 2024. JEE Mains 2024. A particle of mass 5 kg is moving with the uniform speed this in XOY plane. This is XOY plane. XOY plane means this. This is XOY plane. This is X, O, this is Y. Along the line y is equal to x plus 4. The particle is moving along this line. Y is equal to x plus 4. This is the path of the particle. Listen, can you compare this with, compare with y is equal to mx plus c. Compare this with y is equal to mx plus c. So y, x, what is the value of m? M means slope. Slope is 1. Okay. When is the value of slope 1? Guys. Slope 1 means value of tan theta is 1. Right? Slope is tan theta. So if slope is 1 means tan theta is 1. When is the value of tan theta 1? When theta is 45 degrees. Oh. And C is intercept. Intercept is 4 plus 4. Intercept means where the graph is cutting the y-axis. If I say, my dear NEET aspirants, in this particular case, if I say graph starts from this, intercept is 0 because this graph is cutting the y-axis at origin. If I say graph starts from this, intercept is negative. So means graph has to be something like this. This has to be the graph. This has to be the graph. Okay. So here, this angle, my dear NEET aspirants, must be 45 degrees. Why? Because theta must be 45. Then only its slope is 1 and positive and constant. And this, my dear NEET aspirants, this R is given as this intercept. This means intercept C. It is actually C. So we say with respect to the origin, this mass, this is the mass. This is at 4. Now you have to tell me the magnitude of the angular momentum of the particle about the origin. So basically, this is the particle here. Because according to the equation, it says intercept is 4. Means intercept is 4 here. 1, 2, 3, 4. If it was minus 4, I would have made it over here. So if intercept is 4 means it is above the origin. And it is making 45 degrees. And my dear NEET aspirants, it says that this mass 5 kg is moving with the speed 4 root 3. So means at this particular point, the speed of the object V is 4 root 3. Now, what is the angular momentum? Listen to me very carefully. So what I can say in this particular case as, we say L is equal to MV R perpendicular. Okay, MVR perpendicular. Now tell me, my dear NEET aspirants, this is the velocity given over here, mass is given over here, and you need to put the value of R perpendicular. Please tell me in the chats if this is clear till over here. Tell me, oh. Tell me. Okay. Okay. Now, let's find the exact values. See. So, this is the velocity. This is R and this is mass. Mass is also given, velocity is also given R. Now, I'll be making the diagram over here. Listen carefully. This is the object. This is the velocity. V is 4 root 3. Wait. This is R. And this angle is given as 45. Okay, this is R. This is origin. Now, boys and girls, in this particular case, make sure when you write L is equal to, you say M R into V per. You say R perpendicular or V perpendicular, it's one and the same thing. The two must be perpendicular. Now, if this is V, this component will be V cos 45. Because this only will be considering as V perpendicular. Because this component is perpendicular to R, another component is parallel. Now, how much is this? This is V. Cos 45 is 1 by root 2. So, V divided by root 2. So, this is, what is the value of V? That is 4 root 3 divided by, okay, it's not 4 root 3, it is 3 root 2. 3 root 2. So, here also I am writing 3 root 2 divided by root 2. Root 2 will cancel, so it will come out to be 3. Okay, this is V perpendicular. Now tell me what is the angular momentum? That is M R V perpendicular. So L will be, guys, with the help of this equation, we predicted the graph, we predicted the path. When you predicted the path, you calculated R and velocity is perpendicular component and mass is also given. How much is the mass? Mass is 5. What is the value of R? That is 3. What is the, okay, this is V perpendicular. What is the value of R? R is 4. This is 4 into 3. 5 चुके 20, 20 into 30 कितना हो गया? 60. Angular momentum is 60. Is this clear or it is 60 or? What are you writing? 40 root 3. Conservation of angular momentum. Conservation of angular momentum. Okay. Is this clear? Oh? Tell me quickly. Smash the like button. Come on. Make it fast. Now guys, take a look. Conservation of angular momentum. This is also very important, boys and girls. Okay. Do you guys see the level of content that I'm showing you in these sessions? And within a very less span of time, I'm showing you previous year questions of mains along with the pure detailed concept explanation within a very less amount of time. Okay. Thank me after the NEET. Okay. Now, take a look. We say as we know, there is one thing. Force is equal to F is equal to dP by dt. This is the Newton's second law. Rate of change of momentum is equal to force with respect to time is equal to force. This is Newton's second law. Similarly, also in rotational motion, there is Newton's second law. Here you have force, here you have torque. Whatever the role plays force in linear motion, same role torque plays in angular motion. Force is used to move an object if the object is at rest. If the object is at rest, how do you make the object how do you move the object from rest? Apply force. Torque is basically responsible to make the body in rotational motion. If the body is at rest, I want you to rotate this body, apply torque. So here force, here torque is equal to, here momentum, here angular momentum. L means angular momentum divided by dt. This is called Newton's second law. This is called rotational version of Newton's second law. Let's suppose if on an object net torque is 0, if net torque is 0 on an object, torque acting, listen to me directly, bro. Whatever I'm saying, directly remember. If net torque on an object is 0, so we say 0 will be equals to dl by dt. So take it over here. So dl will be equals to 0. dl means change in angular momentum. So if change in angular momentum is 0, means angular momentum is not changed, means angular momentum is conserved. So means whatever is the angular momentum initially, same will be angular momentum finally. Then only angular momentum will not change. That is called conservation of angular momentum. Whenever the angular momentum of the body is something, okay, afterwards it will remain the same, we say angular momentum is conserved. When it is conserved? When net torque is 0. Let's move on to the questions. And we say, how do you write angular momentum? We say I into omega initially. Finally, we say I dash into omega dash. Because in angular momentum of a purely rotating body is I into omega. Finally, it is I dash into omega dash. Like this question, J means 2014. Take a look at this question. What does the question say? A thin circular disk of mass m and radius r is rotating about an axis, passing through its center. There is an axis which is passing through this center. This disk is rotating. Okay, this disk is rotating. Or you can say, this is a disk. It has mass m and radius r and angular momentum, let's suppose I. Sorry, moment of inertia I. Moment of inertia of disk is also I. Okay, yes. Now, my dear NEET aspirants, when it comes to the moment of inertia of disk about this axis, it is mr square by 2. Okay. is rotating about an axis passing through its center with omega. It is rotating with omega. If another disk of mass m by 2, then finally you are placing another disk of mass m by 2. Let me make the diagram something like this so that it is crystalline clear to you. See guys, what does the question say? There is a disk, okay? It is rotating with angular velocity omega. Its mass is m and radius is r. Consider moment of inertia and I. This is initially. Finally, it says that this disk which was having moment of mass m, radius r, moment of inertia I, okay. It says if another disk of m by 2 is placed gently on the first disk, it says another disk is gently placed on the first disk. Okay, its mass is m by 2 and radius is same. Okay, then the new angular velocity. Now what will be the angular velocity of this system? This is it saying. Sir, in this particular case, when you place, we say here we consider net external torque is 0. If net external torque is 0, we say initial angular momentum is equal to final angular momentum. Now guys, we said this has moment of inertia I. This will be having moment of inertia I by 2. Because moment of inertia depends upon mass. Guys, this has mass m by 2. Moment of inertia will be I by 2. This has mass I, m. Moment of inertia will be I. Now, how do we write this? I into omega. This will be equals to I dash into omega dash. I dash into omega dash. Now, I into omega. What is the moment of inertia initially? That is I. Okay. What is the angular velocity initially? Omega is equal to. What is the angular moment of inertia finally? Guys, moment of inertia finally, I dash. I dash. That will be moment of inertia of this plus moment of inertia of this, I divided by 2. That will be 3I divided by 2. So here I can write 3I divided by 2 into omega dash. I and I will cancel. So take it over there. So this will be 2 omega divided by 3 will be equals to omega dash. You can keep this in a box. You can keep this in a box. Okay, absolutely. Take a look. There is a question. A mass m moves in a circle on a smooth horizontal plane. There is a mass m. It is placed on this kind of table, you can say. Kind of table, you can say. Okay. So there is a mass m which is rotating on this table with velocity v naught and radius r naught. And in radius r naught. Okay. The mass is attached to a string. It is attached to a rope. Okay. Which passes through a smooth hole in the plane as shown in the figure. So basically this mass is rotating. It is attached to a smooth a rope, which is passing through, see. This mass is rotating. It is attached to a rope. This rope passes through the hole. We can basically pull this roll. Okay. We can pull this string basically. Okay. As shown in the figure. The tension in the string is increased and the mass is moved to R naught. Now, if you basically pull this string in the downward direction, we said this mass comes closer. It reaches here. Now the radius in which this mass is moving, that becomes how much? R naught divided by 2. When you pull the string, this mass comes closer to the hole. Now it starts rotating in a radius R naught divided by 2. The final value of the kinetic energy will be, it says, what is the value of the kinetic energy here? Okay, guys, listen to me very carefully. Could you please tell me what is the kinetic energy initially? When it was rotating here, sir, kinetic energy initially is 1 by 2 m v naught square. Because here velocity is v naught. Now what will be kinetic energy finally? 1 by 2 m v naught, but we don't know value of v over here. We have to find the value of v. Okay. Now guys, we say, Let's find V naught velocity finally. In this particular case, we also consider angular momentum conserved because no external torque is acting over here. Okay, so my dear, due to this string, we say this is not the external torque. Okay, keep that thing in your mind. We say here angular momentum will be conserved. So we say here angular momentum initially is equal to angular momentum finally. Now this mass is rotating about the center. How do we write the angular momentum? mvr sine theta. So we say m is mass and initially v naught is the velocity. And how much is the radius initially? That is r naught. And what is the angle between? If it is rotating in circles, so this angle would be 90. So sine 90 is 1 is equal to, finally mass is m. Finally mass radius is r naught divided by 2 because it says finally when it is basically pulled to this radius r by 2 and final velocity is v dash. Now m will cancel, r naught will cancel. So v dash will be equals to 2 times of v naught. Now let's find final kinetic energy. So final kinetic energy will be 1 divided by 2 m v square. So 1 divided by 2 m. What is the value of v? That is 2 times of v naught square. So this will be 1 divided by 2m 4 v naught square. 2 1s are 2 2s are. So answer is 2m v naught square. This is the final kinetic energy. Is this clear? Is this clear? There is a question over here. NEET 2017. I would want you guys to focus exactly over here. Guys, smash the like button if you are not liked the session yet. Okay, take a look. Two disks of same moment of inertia rotating about the regular axis passing through the center. You have got two disks. Okay, same moment of inertia passing through the center about, two disks of same moment of inertia rotating about the regular axis passing through the center. You have two disks. These are rotating about this regular axis which is passing through the center. Perpendicular to their plane. This is the plane. It is this axis is perpendicular to the plane of the disk. With angular velocity omega 1 and omega 2. This is rotating with omega 1. This is rotating with omega 2. They are brought in contact. These two are brought in contact. Face to face, coinciding the axis of rotation, face to face, coinciding the axis of rotation. The expression for loss in kinetic energy during the process is amazing question. So basically they are brought in contact. So when they are brought in contact, my dear NEET aspirants, they collide. So collision takes place. We recently studied collision. So this is perfectly inelastic collision in case of rotation. Okay, because they are brought in contact, then they touched. Guys, what is inelastic collision? When the two balls collide, then they separate. What is elastic collision? The two balls collide, then they separate and regain their original shape. When the two balls collide and they stick together, move together, that is perfectly inelastic. Here, two disks are rotating and they are colliding. This is also collision in rotation. And after the collision, they are rotating together. Okay. Now, my dear NEET aspirants, that's why we call it perfectly inelastic collision. And we know in case of perfectly inelastic collision, what is loss in kinetic energy? 1 by 2 m1 m2 upon m1 plus m2 v relative square or u relative square. And my dear NEET aspirants, In case of rotation, we use the same equation. Same equation. See, in case of rotation, we say kinetic energy loss. It will be 1 divided by 2. Here you have mass m1, m2. In rotation, instead of mass, we write moment of inertia. Because moment of inertia plays the same role as mass plays in linear motion. So I can write I1, I2 divided by I1 plus I2. And here you have u relative square, and here you have omega angular velocity. So omega relative square. Oh, sir. This is so amazing. Now tell me, boys and girls. It says that the two disks have same moment of inertia. So what I can write over here? This would be 1 divided by 2. I into I is I square. Divided by I plus I is 2I. Then omega relative square. Omega relative square, that is omega 1 minus omega 2 whole square. This square and this will cancel. So this will be 2 into 2 is 4. I divided by 4 omega 1 minus omega 2 whole square. This is the loss. This is the same question. Another question, please do check this from your end. Very simple. Please give me the signal in the chats if this is crystal and clear till over here. Okay. By the way, I have shown you whatever is important in work, power and energy. I'm going in a sequence. Whatever is important in center of mass, whatever is important in collisions, that I also covered. Whatever is important in a rotational motion, that I also covered. Let's move on to the gravitation. Gravitation. Oh, is this clear? Do smash the like button, boys and girls. Now guys, acceleration due to gravity. Listen to me very carefully. How do we actually define acceleration due to gravity? See, let's suppose you have, this is Earth. Radius of Earth is r, mass of Earth is me, and there is a mass object placed on the surface of Earth, it is m. Now tell me, what is the gravitational force between two masses? Whenever you have two masses, you apply gravitational force. F is equal to g m1 m2 by r square. Here also, gravitational force will act on this mass. If somebody says, how much is the gravitational force on this mass? Force on mass m. F is equal to g m1 m2. M1 is the mass of this Earth that we assume at center, and M2 is this mass, that is M, this M divided by, what is the distance? That is R, because we assume the mass of Earth at center, so R square. Now, if this is a force, we know that if force acts on an object, acceleration is there. We say acceleration will be force upon mass. So acceleration will be force Gm, this m divided by r square into this m. Now, what can I say over here? M and m will cancel. So acceleration will be gm divided by r square. This acceleration we represent with g naught. This is basically, which force is this? This is gravity. Okay, or gravitational force. So I can say, my dear NEET aspirants, this is the acceleration which is due to the gravitational force on the surface of Earth. So this is what we call acceleration due to gravity on the surface of Earth. So this is the acceleration due to gravity on the surface of Earth. As simple as that. Yes, sir. And this acceleration due to gravity G naught, it is Gm divided by Re square. Now, if you put the value of universal gravitational constant, mass of Earth, okay, okay, and then Re square, radius of Earth, this value will come out to be 9.8 meter per second squared. This is acceleration due to gravity. And this is acceleration due to gravity in terms of mass of Earth. We say in terms of density. In terms of density. So this is the expression in terms of mass of Earth. In terms of density, we say this G naught is equal to 4 by 3 pi rho. 4 by 3 pi rho G and R. This is going to be in terms of density. So these are the two expressions of acceleration due to gravity on the surface of Earth. Now, my dear NEET aspirants, if I say, when, see, sir, what is the relation between G naught and R? G naught and this R. We say when mass is constant. Remember this directly, my dear NEET aspirants. I'll show you the question also. If the mass of two planets is given as constant, in that case, acceleration due to gravity is inversely proportional to R square. Because here, guys, we say if this is constant, then only you can say inverse. Now, we say when density is constant. If I say density of two planets is constant, this is pi is constant already. G is also universal gravitational constant is already constant. So we say in this case, G naught is proportional to R, directly proportional. So if somebody says, what will be the graph? Guys, G naught versus R, graph would be directly proportional when density is constant. That is what I say. And if mass is constant, sir, what is this mass constant, density constant? See, I'll tell you. Two planets of same density but different radius, the acceleration due to gravity would be same density. Density of two planets is given as constant. Radius is different. That's what I'm saying. If density is given as constant, G naught is directly proportional to Re. If mass is given as constant, G naught is inversely proportional to Re square. So here graph would be rectangular hyperbola. Here graph would be this. Let's first solve this question only. Now tell me, two planets having same density. One planet, another planet. Density is same. Acceleration due to gravity would be, now we know G naught is equal to 4 by 3 pi G rho R. Guys, if density is constant, G is already constant, pi is constant, 4 by 3 pi is constant, we say G naught is proportional to R. That's what I was saying. So what does that mean? The one with large radius, the planet with large radius will be having more acceleration due to gravity, greater on the larger planet. Like this question. A planet has mass, same density and same acceleration due to gravity as that of Earth. This is the planet. This is Earth. It says density of planet is equal to density of Earth. And acceleration due to gravity, G naught of planet and G of Earth is also same, small g. And universal gravitational constant, G is twice that of Earth. Universal gravitational constant on the planet is 2 times universal gravitational constant on Earth. It is given, so we have to assume it. Okay. The ratio of the radii is, guys, we'll use this equation as, because density is given, G naught is given, so we'll prefer this. Acceleration due to gravity is 4 by 3 pi rho, 4 by 3 pi G rho, we say R. Now guys, this is constant, this is constant, this is constant, even this is constant. So can I say this G into R is actually constant? Because the rest of all the things are constant. Constant, you can say 1. So we say this R will be inversely proportional to G. Absolutely, sir. Because the rest of the things are constant. So that's why I'm saying this is variable, this is variable. Why variable? Because planet and this have different universal gravitational constant. Now, if I say radius of planet divided by radius of Earth. It will be radius is inversely proportional to universal gravitational constant. Now, radius of planet, that is 1 upon this G and P divided by 1 upon G and E. So take this in the numerator. This will be GE divided by 2 times GP. This will be GE divided by universal gravitational constant on Earth. And GP is what? 2 times of GE. G will cancel. So radius of planet divided by radius of Earth, it will be 1:2. Is this clear? Oh? Guys, smash the like button quick. Okay. Acceleration due to gravity above the surface of Earth. Now see, previously object was on the surface of Earth. Now if you are taking an object above the surface of Earth, we say acceleration. See, what is the acceleration due to gravity on the surface of Earth? Gm by r square, because this radius is r. Now if you take it to the height h, so we say gm upon r plus h whole square. Arey sir, simple sir. This is the acceleration due to gravity, gm upon re plus h whole square. In terms of g naught, you can write this expression, acceleration due to gravity above the surface of Earth, in terms of g naught. G naught is the acceleration due to gravity on the surface of Earth. So that will be gh is equal to this gh is equal to g naught into re square divided by radius of Earth plus h whole square. You can keep this in a box. Okay. Now, case number 1. If height is much less than radius of Earth, if you have taken the object to certain height, which is very small as compared to the radius of Earth. Okay, radius of Earth, when you say it is 6,400 kilometers. So if the height is between 0 meters to 10 kilometers, so 10 kilometers is very small as compared to 6,400 kilometers. In that particular case, we say acceleration due to gravity will remain the same. It will not change. Whatever is the acceleration due to gravity on surface, same will be at that height, which is very small. Like if this is surface, if you take the object to 500 meters, sir, will it remain the same? It will remain the same, bro. At 500 meters, 1 kilometer, 2 kilometers, up to 10 kilometers, we assume it to be same. If height is much less than re, sure, height is much less than radius of Earth. In this particular case, we say if height is much less than re, that is, height is 5% of radius of Earth. Like it can be 16 kilometers, 32 kilometers, 64 kilometers, 128 kilometers. Okay. In this particular case, acceleration due to gravity at that height would be g naught 1 minus 2h by r. You have to remember. This is when height is something like greater than 10 kilometers, basically 16, 32, 64. So if it is less than 10, then it consider G naught only. This is valued only when the height is between 10 kilometers to 500 kilometers. This point is important. This point is important. Percentage change in the G at smaller height. See. If let's suppose there is an object, its acceleration due to gravity here is G naught. If you take it to the certain height, we say acceleration due to gravity, let's suppose change. How many percent? 5%? How many percent? 10%? 20%? How can you find this in percent? 20%, 30%, how many percent it will change? This is the formula. Delta G divided by G into 100 minus 2h by R into 100. This is the way to find percentage change in acceleration due to gravity. This is the way to find percentage change in acceleration due to gravity at height h. Okay? This is the way to change the acceleration. This is the way to find the acceleration due to gravity at height h. There is a question which was recently asked in JEE 2026. The height in terms of radius, of Earth are at which acceleration due to gravity is G by 9, when G is the acceleration due to gravity on the Earth's surface. It says that, let's suppose there is an object which is placed on the surface. Its acceleration due to gravity is G. If you take this object to certain height, where its acceleration due to gravity, GH, will be G divided by 9. What will be that height? This is actually the question. Now tell me, what is the acceleration due to gravity as? Acceleration due to gravity above the surface of Earth as GH is equal to G naught into R square upon R plus H whole square. This is the acceleration due to gravity above the surface of Earth. G naught into R square upon R plus H whole square. Yes. Now, what is the value of this GH? This will be G divided by 9. G divided by 9 is equal to G naught into R square, G naught into R square upon R plus H. Okay. R plus H. This is also actually G naught, because either you say G naught by 9 or G naught, it's one and the same thing. So this would be R plus H whole square. Now G naught and G naught will cancel. So this is R square upon R plus H whole square. Take this whole square over here. It would be R upon R plus H. It would be under root of 1 by 9. Because if you take the square here, it will become a root of 1 by 9. So R upon R plus H. It would be simply 1 by 3. Take it over here. This would be 3R is equal to R plus H. If you take it here. So 3R minus R is 2R is equal to H. This is the answer, 2R. If you take it to a height H is equal to R, we say its acceleration due to gravity would be G by 9. At what height above the surface of Earth the value of G decreases by 2%? Okay. Let's suppose this is the acceleration due to gravity on the surface. If you take this to certain height, here acceleration due to gravity G decreases by 2%. So G decreases by 2%. You have to tell me what is this height. This is the question on this. This is the question on this. Percentage change in G at smaller height. So what I can say, this in mathematics, the way how we write this is delta G divided by G into 100. This is what we call percentage change in G. So this is given as 2%. Even I would say minus 2%. Sir, means delta Y divided by Y into 100. Does that mean this is percentage change in Y? Absolutely. Delta x divided by x into 100, percentage change in x. This is percentage change in y. Now guys, we say as delta g divided by g into 100 is equal to minus 2h divided by r into 100. What is the value of this percentage change in g? This is given as 2%. This is given as 2 is equal to minus, I would say minus 2. Minus 2h divided by r. Because when they say decrease, decrease means negative. 2h by r into 100. And by the way, what is this r? R is the radius of earth. This is 6400. 0, 0, 0, 0. 2 and 2 will cancel. Minus and minus will cancel. So this h comes out to be equal to 64 kilometers. So if you take an object to the height of 64 kilometers, we say acceleration due to gravity will decrease by 2%. A body of weight 144 Newton on the surface of earth. Guys, see, there is an object. How do you define weight? Weight actually means mg. Weight means mg. We say weight. Weight means m into g. So g is the acceleration due to gravity on surface of earth. Weight means the force which is acting on the object on the surface of earth. This weight is given as 144 Newton. So value of mg or mg naught is given as 144 Newton. When it is taken to a height h is equal to 3r, you have taken to this object h is equal to 3r. You have to tell me what is the weight here. So here weight will be mass into gh. If you say on the surface weight is m into g naught, here weight would be m into gh. Absolutely. So you can say in this particular case this is m. What is the acceleration due to gravity above the surface of earth? Recently you studied. Acceleration due to gravity above the surface of earth is, I would say, g naught into r square upon r plus h whole square. Yes. So you can write this over here. That is g naught into r square upon, or you can directly write g naught into r square upon r plus h whole square. Now guys, tell me one thing. M into g naught, it is 144. So this is 144 into r square divided by, this is r plus, what is the value of h? 3r whole square is equal to 144 r square divided by 3r plus r is 4r. 4r whole square is 16r square. 16r square. So can I say in this particular case r square cancel, 16 ones are 16, 9s are, so 9 Newton. So its weight at h is equal to 3r is 9 Newton. Okay. Then you have, my dear NEET aspirants, acceleration due to gravity below the surface of earth. We studied on the surface of earth, above the surface of earth, now below the surface of earth. This is the surface. I would say if you go at depth d, this is the depth d, if you place the mass here m naught, or this is how we define in two ways. If you go at depth d, or from the center, if you move at r distance, small r distance. So what is this, sir? This total is radius. So I can say, sir, radius in this particular case would be r plus d. Absolutely. Sir, then this r would be r minus d. Absolutely. Now, at depth d, or we say, I'll write over here, at distance r from the center inside. So at distance r from the center inside, this is the acceleration due to gravity. Gm into r, small r, this distance, divided by capital R cube. Capital R is the radius. Okay. And you can say, sir, this r is actually, this r is this total, capital R minus this d. So r is capital R minus d. You can write it r minus d over here. So this will be in terms of depth d from the surface. I hope you are able to figure out what is the difference between these two expressions. This is in terms of r. R is the distance from the center to that point inside. This is in terms of depth. Yes. Now, you can, in terms of G naught, you can write it like this: G naught into 1 minus d by r. In terms of G naught, acceleration due to gravity on the surface. Percentage change in G. How much acceleration will, how many percent, like, if an object was here, if you take it to this depth, how many percent G is going to change? So this is how we define percentage change in G. In depth, percentage change in G in height is different, percentage change in G in depth is different. Delta G by G naught into 100 is equal to minus d by r into 100. Over there it was minus 2h divided by r into 100. Here it is minus d divided by r into 100. If the density of the planet is double than that of the Earth and radius is 1.5 times than that of the Earth, the acceleration due to gravity would be, okay, you have got a planet, you have got Earth, okay. It says that if the density of the planet is 2 times density of Earth, okay, and the radius is 1.5 times, the radius of planet is 1.5 times, that is 3 divided by 2 times radius of Earth. The acceleration due to gravity on the surface of the planet would be, guys, you'll be using again this formula. Acceleration due to gravity is 4 by 3 g rho pi into r. Now, what is g is constant? Okay, this is not constant. Okay. So g is constant. So can I say this acceleration due to gravity, it depends upon what? Density and radius. Yes, this is the expression. Because constant we always remove. Now it depends upon density and radius. Now acceleration due to gravity on planet upon acceleration due to gravity on Earth. Okay, it would be, in this particular case, acceleration due to gravity on the planet, that is density into radius. Density is 2 times density of Earth and radius is 3 by 2 times radius of Earth, because it is density into radius. Its density is 2 times radius of Earth. Sorry, density is 2 times density of Earth. Radius is 3 by 2 times radius of Earth divided by density of Earth into radius of Earth. This and this, this and this, this and this. So this comes out to be 3:1. So GP is equal to 3 times GE. Is this clear? Tell me. Okay. Yes. Let's move on to the next one. Okay. If the radius of Earth shrinks by 1.5%, then the value of acceleration due to gravity changes by, guys, see, this is Earth. Let's assume acceleration due to gravity on the surface is g. And what is the value of G on the surface of Earth? Gm divided by R. Now, if radius shrinks, listen to me very carefully. This is a very good question. Okay. Just a second. Now, guys, let's suppose I'll tell you one more important point over here. Let's suppose we say y is equal to x raised power n. Y is equal to x raised power n. We have this. Now, my dear NEET aspirants, y is a physical quantity which depends upon x. Y is a physical quantity which depends upon x. Now, if x changes, we say y changes. So we say, how do we write? We write delta y divided by y into 100. This is what we call percentage change in y. We write it something like this: power down, n down, delta x divided by x into 100. What does it mean? If x changes, we say y changes. Okay. We say y is equal to x raised power, let's suppose minus 2. How do we find percentage change in y? Delta y divided by y into 100. We write it power down, minus 2 down, delta x divided by x into 100. This is called error analysis method. Now, my dear NEET aspirants, G is a physical quantity which depends upon radius. If radius changes, G changes. Now, when the question says if the radius of the earth shrinks by 1.5%, radius of the earth decreases by 1.5%, then the value of acceleration due to gravity changes by. Now, can I write it like this? G is proportional to, take this in the, Gm is constant, take this in the numerator, r raised power minus 1. Okay, you can say r raised power minus 1. How can you find percentage change in G? Delta G divided by G into 100. It will be equals to power down minus delta R divided by, okay, Gm by R square it is. Sorry. Okay, so this is minus 2 delta R divided by R into 100. Minus 2 delta R divided by R into 100. This is how we find the percentage change in G. Now tell me, what does it say? What does it say? If radius of Earth means delta R divided by R into 100, if this is given as minus 1.5%, because it said it decreases by, shrinks by, what will be this? So you can say, so delta G divided by G into 100, you can write as minus 2 delta R divided by R into 100. This is given as minus 1.5%. Now, minus into minus is plus 2 into 1.5. So this will be 3%. I hope this is crystalline clear. I hope this is crystalline clear. This I'm giving you as homework. This you'll be doing from your end. Okay, one more important thing, guys. See, this is also important. Acceleration due to gravity, graph. If I say inside acceleration due to gravity is G naught R divided by this R. Okay, we recently studied this. Okay. So this is inside. G naught into R divided by this R. G naught, okay, instead of this, you can write, or you can directly say G naught is proportional to this R. Directly proportional to this R inside, and outside. Guys, you can write it like this: outside. See, R is basically variable. You can say it like this: G naught into RE square divided by R square. And R in this particular, you can consider this. R is variable. For outside point, R is greater than radius. For inside point, R is less than radius. So RE plus H is this. So for outside, G naught is inversely proportional to R square. And for inside, G is acceleration due to gravity is directly proportional to R. So my dear NEET aspirants, inside directly proportional, outside inversely proportional. Okay, inversely proportional. So what I can say in this particular case, graph is going to be, guys, this is the center. So from center to surface, at surface value of small r is capital R. Inside, small r is less than radius of earth. Outside, small r is greater than radius of earth. At surface, small r is equal to capital R. So till surface, G is directly proportional to R inside earth. Outside, it is rectangular hyperbola because G is inversely proportional to R square. Very, very important graph. Very, very important graph. Very, very important graph, boys and girls. One more important question I just want to tell you over here. Is this clear? Oh? Is this clear? Oh, tell me in the chats. Oh, let everybody enjoy in the chats. Why should we block them? Huh? Everybody has the right to be in the chats. Na? Huh? Let these nibba nibbis enjoy here. Okay. Now take a look. And smash the like button. No, everybody, make sure. Okay. Now, gravitational potential due to a hollow sphere. See. We say if you have a mass, point mass. Due to this point mass, potential at r distances, V is equal to Gm divided by this r. Okay, I would say minus Gm by r in this particular case. Now, my dear NEET aspirants, if you have this potential, this hollow sphere means football, which is hollow from inside. Its radius is r. At outside point, small r is variable. We say potential would be minus Gm by r, simply. Because from a very large distance, we consider it a point only. Because if you hold a football or a big balloon from a large distance, we assume it to be a point only. This is outside. At the surface, we say where r is equal to capital R. At surface where this capital R is equal to small r, put here capital R. So it would be minus Gm by r. And my dear NEET aspirants, if you ask me inside the surface, it would be same as surface. That is minus Gm by capital R. If you say graph, guys, we say this is graph between mod of V and R. That's why I have made the graph from the upper side. Otherwise, the graph will be from lower side. So my dear NEET aspirants, between mod of V and R, we say from inside, this is here, value of R is equal to 0. This is center. From center to surface, guys, see, G is constant, mass is constant, radius of earth is constant. So this is constant. So from, I would say, center to surface, it means inside. So from here to here, potential is constant. Outside, it is variable, inversely proportional to small r. Because capital R is constant, small r is variable. So from center to surface, we say potential is constant. Outside, it is inversely proportional to small r. So in reality, when this potential is negative, we make the graph something like this. So that was the graph of mod. Something like this. Due to a solid sphere means cricket ball, which is not hollow from inside, which is filled. So when it comes to this cricket ball, solid sphere, we say potential would be, my dear NEET aspirants, at outside point. It is minus Gm divided by small r. Okay. Same as hollow outside. Okay. Consider it a point mass only. On the surface, value of small r is capital R, because when you move towards the surface, so this would be the value of small r, which is equal to capital R. So minus Gm by capital R. And my dear NEET aspirants, when you say inside, listen to me very carefully. Inside here it is minus gm by 2r cube, 3r square minus r square. This would be potential inside the surface at what distance? At what distance? At r distance. At r distance. In case of hollow sphere, it was constant. In case of hollow sphere, whatever is the potential inside, same is on the surface, but here it is different. So gm, m is the mass of the sphere, 2r, r is the radius. This r is radius, r is radius. And small r is the distance inside from the center where you have to find the potential. If I say at center, guys, see, at center. What is the value of small r? 0. Array, you measure this small r from center only, na? At center it is 0. If you put over here 0, v at center, v naught, it will be minus gm divided by 2r cube. Then this would be 0, 3r square. R square and cube will cancel. So v naught at center would be minus 3 divided by 2 gm divided by r. Okay. Okay. At surface it is gm by r only, which I told you. Here it is center 3 by 2. Okay. What is the value of potential on the surface? Gm by r. So 3 by 2 times of this surface. And here graph in this particular case, potential versus this, it would be like this. This is mod of V versus R. And in reality, it is something like this. Okay, guys. If I say, what is the, this is R is equal to 0. What is the potential at center? Mod of V. 3 by 2 times of Gm by R. Okay, this is potential at surface. What is the value of potential? This is, sorry. This is potential at center. What is the potential at surface? That is Gm by R. Which one is greater? Magnitude wise. Sir, this is greater. Why? Because this is 3 by 2 times. 3 by 2 means 1.5. So at surface, this is, at center, it is large. Then at surface, this is the potential. That's why it is decreasing. And then if you see outside, mod of V, it is gm divided by small r. So outside, till here it is inside. Till here it is inside. Mod, okay. And this is outside. So my dear NEET aspirants, in reality, the graph is like this because this is negative. This graph is extremely important. Very, very important. If they ask you the question from this topic, they will surely ask the graph because they have asked this so many times previously. Similarly, if I say potential due to a uniform ring, if there is a ring which is having the mass and radius r at x distance, we say potential simply in this particular case is minus gm upon r plus x whole square. R square plus x square, then we say root. Okay, r is the radius, x is the distance where you have to find the potential. At center, my dear NEET aspirants, what is the value of x? 0. At center, if you move towards the center, at center, we say value of x is 0. So if value of x is 0, you put 0 over here. So potential would be minus gm by r. So minus gm by r. Because if you put, see, minus gm upon, this is 0. So root of r square. Square root cancels. So minus gm by r. Okay. Okay. Yes. This is when x is much greater than r. Let's suppose this is a ring. This is a ring. Okay, this is r. If you have to find the potential here, this is x. In this case, x is much greater than r. So at this point, we say potential is minus gm by r. Okay, when this is the ring, this is the ring. If I say at this point, this is x, here x is much less than r. So we say in this case, potential would be minus gm by r. Here it is minus gm by x, very far from the ring, very close to the ring. Potential close to the ring, potential far from the ring. Are you getting me? Tell me. Okay. And if you make the graph between potential versus R, it would be like this. Because very close to the ring, guys. What is the potential due to the ring at the center? G constant, M constant, R constant. So this entire term is constant. What is the potential very close to the ring? This is very close. Very close. G constant, M constant, R constant. So constant. And very far, it is inversely proportional to X. So V versus X, V versus X. So this is very close. Okay. V is constant. This is very far. V is inversely proportional to X. Mod of V, mod of V, mod of V. In reality, if you make the graph, it would be from the lower side. Gravitational potential energy. Just one more topic and we are done. Just one more topic, we are done. It will take us hardly 5 more minutes. Okay, 5 more minutes and we are done. Gravitational potential energy of Earth mass system. Guys, see. If let's suppose I say this is the Earth. Okay. And you have placed an object on the surface of Earth. Okay. If this is the Earth, you have placed an object on the surface of Earth. Its mass is m. If somebody says, what is the potential energy between this mass and Earth? We say potential energy between mass and Earth is, you assume Earth to be at center. This is the radius r. You say potential energy is, that is simply G like this minus G m1, that is mass of Earth, m2, that is this mass, divided by radius r. G m1 m2 divided by r. It is on the surface. U1, let's call it U1. Now, if you take this mass to the height h, okay, we say its final potential energy would be minus G, mass of Earth is m, mass of this mass is m, divided by what is the radius, that is r plus h, Because potential energy between two masses is minus G m1 m2 divided by r. I am using this formula only. When the object is on the surface, it is minus G m divided by r. When the object is at height h, in that case, minus G m divided by r plus h. Now you find change in potential energy. How much is the potential energy change? Delta U. That is U final minus U initial. So that will come out to be like this. After solving, it would come out to be like this. Further, when you solve it, you can write it like this also. This is the change in potential energy. This is the change in potential energy from surface to height h. Okay. Now. My dear NEET aspirants, if the height is, let me see if you guys can see this. Yes. If the height is very, very small, okay, if you are taking an object to very small height, so in that particular case, this quantity would be very small, this quantity h, and radius of Earth is very large. Very small quantity divided by very large quantity, this would be approximately 0. If height is very, very small, h is much than radius of Earth, 2 meter, 3 meter, 4 meter, etc. Delta would be 1 mgh upon 1 plus, this term would be 0. That is mgh divided by 1. So that would be mgh. That's why we take the potential energy of an object at height h, mgh. I hope you got the feel of this topic. Now see the question. JEE 2026 means. See the question, boys and girls. See the question. A body of mass m is taken from the surface of Earth to the height equal to the twice radius of Earth. Okay. This is the radius of Earth. There is an object which has taken to this h is equal to 2r. Then the increase in potential energy means change in potential energy. Change in potential energy is mgh divided by 1 plus h divided by r. Array, this is change in potential energy, na? mgh upon 1 plus h by r. Absolutely. Now you can write it like this. This would be mg. What is the value of h, guys? That is 2r. Divided by 1 plus h. What is the value of h, guys? 2r divided by r. Because you are taking it to the height 2r. R and R will cancel. 2 plus 1 is 3. So this would be 2 mgr divided by 3. 2 mgr divided by 3. JEE 2026 question is this. Same question. Same question. The change in the potential energy when the object is raised to h is equal to nr. Okay. It says h is equal to nr. If an object is taken to h is equal to nr, what would be the change in potential energy? Guys, see, delta U is equal to mgh divided by 1 plus h divided by r. So mg, instead of h, it is nr divided by 1 plus nr divided by r. R and r will cancel. So this is n upon 1 plus n in the denominator. Then it would be mg into r. Escape velocity. Take a look. Just one last question, because I have told you all the important questions of gravitation. Gravitation is the highest weightage chapter in the entire NEET category. Escape velocity, the minimum velocity with which you escape from the gravitational field of Earth. This is Earth. This is an object. If you want this object should escape from Earth, you give it certain velocity. Guys. Escape means, if let's suppose this is an object. See, if this is Earth, let's suppose there is an object. If you want to send this object so that it should not come back, you are giving certain velocity, it goes, and falls back. You are giving more velocity, it goes, again falls back. You are giving more velocity, it goes, again falls back. You are giving more velocity, it goes, and it does not come back. This velocity is what we call escape velocity. That velocity with which an object does not come back, that is what we call the escape velocity. Guys, smash the like button. This is what we call escape velocity. And this escape velocity, boys and girls, is under root of 2gm divided by r. And this, due to this escape velocity, it goes to basically out of the gravitational field of Earth. That's why it does not come back. And it is 2gm by r. G is the gravitational constant, universal gravitational constant. M is the mass and r is the radius. And how much is this? It is 11.2 kilometer per second. So if you throw an object with 11.2 kilometer per second, it does not come back. Okay. Yes. One more important thing. This is escape velocity in terms of mass of Earth. If I say escape velocity in terms of density, this is the escape velocity in terms of density. V is equal to R under root of 8 divided by 3 g rho into pi. Now guys, when we say, when we say, boys and girls, when mass is constant, this escape velocity is inversely proportional to radius. When mass of the planet is constant, we say escape velocity is inversely proportional to radius. So graph would be rectangular hyperbola. Okay. V is inversely proportional to this root. Now we say when density is constant, my dear NEET aspirants, in that case, escape velocity is directly proportional to this radius of the planet. So graph would be the straight line. Graph would be the straight line. Okay. Yes. The ratio of escape velocity at Earth to the escape velocity at planet. This is Earth. This is planet. This is planet. Okay, this is Earth. So you are launching an object with escape velocity here. You are launching an object with escape velocity on the planet. What does it further say? Okay. whose radius and mean density, radius of planet is given as twice that of Earth, 2 times radius of Earth. Density of planet is given as 2 times density of Earth. It says what is the escape velocity of planet divided by escape velocity of Earth. Okay. So you are launching an object from Earth, you are launching an object from planet. So this is density and radius given. You have to tell me ratio of escape velocity. Guys, see, we say escape velocity is equal to, recently we studied in terms of density, because density is given R under root of 8 by 3, R under root of 8 by 3 G rho pi. G rho pi. Now guys, G is constant, pi is constant. We say escape velocity is proportional to radius into density, root of density, because the rest of the things are constant. Now escape velocity of planet divided by escape velocity of Earth, it would be, okay, escape velocity of Earth to the planet, it is saying escape velocity of Earth divided by escape velocity of planet, it is, that is radius of Earth. Radius of Earth is Re. Density of Earth is rho e divided by radius of planet. What is the radius of planet? 2 times the radius of Earth. Density of planet, that is 2 times density of Earth. So root of 2 times density of Earth. Okay, here also we need to apply the root, na? Because root, so root density of E, root, this and this will cancel. So it is 1 upon 2 root 2. This is the ratio. This question I am giving you as homework. Please do check this from your end. Okay. Okay. Okay, by the way, one more important thing. If this is the Earth, around the Earth, if you launch a satellite, the velocity with which the satellite revolves around the Earth, that is what we call orbital velocity. The velocity with which the satellite revolves around the Earth is called orbital velocity. And satellite is what? That we launch. So the object which revolves around the planet, that is what we call satellite. So this is the orbital velocity of the satellite under root of gm. M is the mass of Earth divided by r plus h. H is the height at which you have launched that satellite. This is satellite. This is satellite. This is the orbital velocity of satellite. Okay, energy of satellite. Just 1 second, please. Sorry. Energy of satellite, boys and girls. See, if this is Earth, radius of Earth is r. You have launched a satellite at height h. This is mass m. Now, if this is revolving, if somebody asks you, what is the energy of the satellite? It will have two energies. First is, since it has mass and it has velocity, it is in motion, it has kinetic energy. This is the kinetic energy of a satellite. G, universal gravitational constant, mass of Earth, mass of satellite divided by 2r. R is this distance. From center to that. This is the radius r, this is height h. R plus h is small r. This is small r. Now they will also have potential energy. Why? Whenever you have two masses, they have potential energy. This mass and mass of Earth, they have potential energy. Okay. So potential energy will be minus G capital M small m divided by r. This is kinetic, this is potential. And then you have total. Total energy is, we say kinetic plus potential. So kinetic plus potential is basically total. So total energy is kinetic plus potential. This and potential is, I would say, minus. So this would be total. This would be total. So if somebody asks you to make the graph, guys, only kinetic is positive. So energy versus R. Kinetic energy is positive, graph will be from upper side. Total energy and potential energy is negative, graph is from lower side. Why? Because see, total energy is negative and this is also negative. And it is inverse relation. That's why graph is something like this and this. Do let me know in the comments when I end the stream, how was the session? And do smash the like button. Okay. Do let me know in the comments how was the session. Take care and bye-bye. Thank you so much.